Knob and tube wiring is not a type of insulation. It is a method of electrical wiring that was commonly used in the early 1900s. The wires are run through holes in wooden knobs and tubes. These wires themselves are insulated with a cloth or rubber material, but the method of wiring itself is not an insulation type. RHW and TW are types of insulation for electrical wires. RHW stands for resistant heat wire. It indicates that the wire is resistant to heat and can be used in high temperature applications. TW stands for thermoplastic wire. It indicates that the wire is insulated with a thermoplastic material. Knob and tube wiring has several characteristics. Firstly, it typically uses single conductor wires. Each wire, carrying either the hot or neutral current, is run separately along its route. Secondly, the wires are supported at intervals by porcelain knobs, which are nailed or screwed to the building structure. Thirdly, where the wires pass through wooden structural members, such as studs or joists, they are protected by porcelain tubes. These tubes prevent the wires from coming into direct contact with the wood. Fourthly, knob and tube wiring systems do not include a separate grounding conductor. This is a significant safety concern by modern standards. Fifthly, the splices in knob and tube wiring are typically soldered and wrapped with insulating tape. These splices must be made in accessible locations and cannot be concealed within walls or ceilings. RHW insulation is designed to withstand higher temperatures than some other types of insulation. This makes it suitable for use in applications where the wire may be exposed to heat, such as in certain types of lighting fixtures or near heating equipment. TW insulation is a general-purpose thermoplastic insulation that is commonly used in a wide range of applications. It is resistant to moisture and many chemicals, making it a versatile choice for general wiring purposes. When selecting wire and insulation types for a specific application, it is important to consider several factors. One must consider the ampacity or current carrying capacity of the wire. This must be sufficient to handle the expected load without overheating. One must consider the operating temperature. The insulation must be rated for the maximum temperature that the wire is expected to reach in its environment. One must also consider the environmental conditions. The insulation must be resistant to moisture, chemicals, and other factors that could degrade its performance. One must also consider the applicable electrical codes and standards. These codes specify the types of wiring and insulation that are permitted for different applications. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations. In the NEC, various articles and sections provide guidance on wiring methods, insulation types, and other requirements for safe and reliable electrical systems. For example, NEC Article 310 covers conductors for general wiring, including information on ampacity, insulation types, and installation requirements. NEC Section 310.15 provides tables for determining the allowable ampacities of insulated conductors based on factors such as conductor size, insulation type, and ambient temperature. NEC Article 334 covers non-metallic sheathed cable, which is a common type of wiring used in residential buildings. It specifies the types of insulation that are permitted for use in non-metallic sheath cable, as well as the installation requirement. NEC Article 394 covers concealed knob and tube wiring, which is permitted only under certain conditions. It specifies the requirements for the installation of knob and tube wiring, including the spacing of knobs and tubes, the protection of wires passing through structural members, and the type of insulation that is permitted. When working with electrical wiring, it is essential to follow safe practices to prevent electrical shock and other hazards. Before working on any electrical circuit, always turn off the power at the breaker panel. Use a voltage tester to verify that the circuit is de-energized before touching any wires. Use insulated tools to prevent electrical shock. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. Knob and tube wiring is an outdated wiring method that is no longer permitted for new installations in most jurisdictions. However, It is still found in many older homes. If you have knob and tube wiring in your home, it is important to have it inspected by a qualified electrician to determine if it is safe. In some cases, it may be necessary to replace the knob and tube wiring with a more modern wiring system. Modern wiring systems typically include a grounding conductor, which provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. Common types of modern wiring include non-metallic sheathed cable, metal-clad cable, and electrical metallic tubing. Non-metallic sheath cable, also known as NM cable or Romex, is a type of wiring that consists of two or more insulated conductors enclosed in a non-metallic sheath. It is commonly used in residential buildings for branch circuits and feeders. Metal-clad cable, also known as MC cable, is a type of wiring that consists of two or more insulated conductors enclosed in a metallic sheath. It is used in both residential and commercial buildings for branch circuits, feeders, and services. Electrical metallic tubing, also known as EMT, is a type of rigid metal conduit that is used to protect electrical wires. It is commonly used in commercial and industrial buildings for branch circuits, feeders, and services. When replacing knob and tube wiring, it is important to follow all applicable electrical codes and standards. This includes using the correct size and type of wire, installing the wiring properly, and grounding the system effectively. It is also important to obtain the necessary permits and inspections from the local building department. The selection of wire size depends on the ampacity required for the circuit. The ampacity is the maximum amount of current that a wire can safely carry without overheating. The NEC provides tables that specify the allowable ampacities of different wire sizes based on the insulation type and ambient temperature. For example, a 14 American wire gauge or copper wire with TW insulation has an ampacity of 15 amps at an ambient temperature of 30 degrees Celsius. A 12 AWG copper wire with TW insulation has an ampacity of 20 amps at an ambient temperature of 30 degrees Celsius. A 10 AWG copper wire with TW insulation has an ampacity of 30 amps at an ambient temperature of 30 degrees Celsius. The selection of circuit breakers also depends on the ampacity of the circuit. Circuit breakers are designed to protect electrical circuits from overcurrents, which can cause overheating and fires. The circuit breaker should be sized to match the ampacity of the wire. For example, a 15 amp circuit should be protected by a 15 amp circuit breaker. A 20 amp circuit should be protected by a 20 amp circuit breaker. A 30 amp circuit should be protected by a 30 amp circuit breaker. When installing electrical wiring, it is important to follow the manufacturer's instructions and all applicable electrical codes and standards. This includes properly securing the wiring, making connections correctly, and grounding the system effectively. Improperly installed wiring can be a safety hazard and can lead to electrical shock, fires, and other problems. Grounding is an important safety measure that helps to protect people from electrical shock. A grounding system provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. A grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, that is connected to the electrical panel. The grounding electrode is connected to the neutral conductor in the electrical panel, which provides a path for fault current to flow back to the source. All electrical outlets and appliances should be properly grounded. Grounding can be achieved by using 3-wire outlets and plugs, which have a grounding pin that is connected to the grounding system. In addition to grounding, ground fault circuit interrupters, or GFCIs, are another important safety measure that helps to protect people from electrical shock. GFCIs are designed to detect ground faults, which occur when current leaks from a circuit to ground. When a ground fault is detected, the GFCI trips the circuit and cuts off the power, preventing electrical shock. GFCIs are typically required in bathrooms, kitchens, and other areas where there is a risk of water exposure. Surge protectors are another important safety measure that helps to protect electronic equipment from damage caused by voltage surges. Voltage surges are sudden increases in voltage that can damage sensitive electronic equipment. Surge protectors are designed to absorb voltage surges and prevent them from reaching the equipment. Surge protectors are typically used to protect computers, televisions, and other electronic devices. Electrical safety is an important consideration for all homeowners and renters. By following safe practices and taking precautions, it is possible to prevent electrical shock, fires, and other hazards. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. Remember to always turn off the power at the breaker panel before working on any electrical circuit. Use a voltage tester to verify that the circuit is de-energized before touching any wires. Use insulated tools to prevent electrical shock. Wear appropriate personal protective equipment, such as safety glasses and gloves. By understanding the basics of electrical wiring and safety, you can help to protect yourself and your family from electrical hazards. Always consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. Stay safe and be informed when dealing with electricity.